So if you are hot as hell, raise your hand. Well, never mind, actually. That might be a bad idea. I'm really excited to be in Amsterdam today. The first time I traveled outside the US, I was 10 years old, and I remember being in Amsterdam main station on my way to Belgium somewhere. That's not about all I remember, but it sort of feels like a little bit of home in that way. So my name is Peter Chittum. Come on in. Welcome, everybody. I work for Salesforce, which means we are going to talk about enterprise software. Who here grew up wishing to work in enterprise software? Yeah, I didn't either. It's kind of funny how it works that way, but I've been in enterprise software now for over 15 years, and it's kind of become my career, and actually, I have a great time doing it. When I first submitted this talk, I called it when one more XML HTTP request is too much. Since then, I think I prefer the cleaning up your cruddy API. The API I'm going to talk about is the Salesforce data API that we have. Salesforce is about customer data. And that means a lot of our API deals with getting data into and out of our system efficiently. We always start with actually a slide that says, if I talk about anything that's not actually in the product today, don't base your purchasing decisions based on this. But that's OK, because none of you are purchasers anyway. It's just a little dance that we have to do working for Salesforce. And speaking of that, who here knows something about Salesforce? Any customers? A couple of customers. Oh, that's good. All right, so who here thinks of Salesforce as that big CRM company? Anyone think of us as the platform company? That's certainly how we want to think of ourselves. Who here has no idea what Salesforce do? OK, and that's fine. So Salesforce is, oh, I forgot the little fade. Yeah, OK, that's pretty. So Salesforce does enterprise software. The two main components that we talk about in developer relations have to do with Salesforce as platform. And the two pieces of the platform we talk about most are Heroku and Force.com. Who here uses Heroku? A few people. Who here uses Heroku but didn't know it was Salesforce? Yeah, so and that's fine. It's a lot of people don't. But in general, Heroku tends to be customer-facing applications. Heroku isn't the platform as a service I'm going to talk about today. Heroku is essentially an application container. You deploy your code. We detect what kind of application it is, and then we marshal up the services together on Amazon Web Services to host an application. What I'm going to be talking about is the other side of our platform, which is Force.com, which is essentially, yes, we started as a CRM company, and we became a very big CRM company. And along the way, we realized that, hey, we actually have some functionality that could become a platform. In other words, we can maybe make it so that if somebody were to, if somebody wanted something custom to track along with their CRM, we could maybe help them put that in place and have it run alongside their other data. And then we eventually realized, actually, we could probably just have people create new custom applications. And today, that's what we have. So we have applications that kind of fit across the spectrum of front office applications running in our hosted platform. So that's kind of the background. And the important thing to understand about that is the architecture that we have is multi-tenant. Anyone here either worked with or built a multi-tenant system? A few people. So for those of you who don't understand multi-tenancy, it essentially means we have a very small number of actual installations of our product. They're all hosted by us. There is no on-premise Salesforce. It doesn't exist. But across those very small numbers, we're hosting about 150,000 customers. So those are customers as small as little businesses, as big as Coca-Cola, for instance. So everything from big to small. The nice thing is that because of multi-tenancy, we have one version, one code base, and every time we do an update, which is 3 major releases per year, everybody gets updated. So we never have to. One of the big pain points of enterprise software is I go customize it, and then the next upgrade comes out, and then it's like an 18-month release cycle to go through the process of the upgrade, and we break things. And we don't do that. We release 3 times a year. We don't break things. And I'll talk a little bit about why that is when we come to our API. But essentially, what it looks like is we have a whole bunch of instances, and I have them called pods up here. Actually, our PR team doesn't like us calling them pods. Pod stands for point of delivery. It's a particular type of architecture. And essentially, each point of delivery, each instance is hosting about 8,000 Salesforce customers, and we have them in data centers across North America. We have data centers in the United Kingdom, Germany, about to open one in France, one in Japan. So we have them kind of all over the world. And a big part of our business now, and a very growing part of our business, is people who are entrepreneurs building applications and selling them into our customer base. 150,000 customers is a decent customer base to sell into when they're already using a dedicated platform that has a well-defined set of APIs that you can build applications for. So that's part of what we do. What I want to focus on is about our API. As I said, in the world of enterprise software, it's no good having data sitting in your system if it can't interoperate with other systems. Okay? And so we've done APIs for a long time. In fact, we have had APIs longer than we've been able to allow developers to customize with code on our platform, because we realized how important that was early on. Our earliest API is over 10 years old. It was SOAP-based API. Everybody did SOAP then. Who loves SOAP? Nobody. Yeah. And then along came the REST-based architecture and REST-based pattern of accessing APIs. Initially, this was mostly thought of, I think, as kind of a mobile API, and so we sort of implemented it this way. And we have this basic data API. And one of the things about our API is, just like you can add new things that you store in Salesforce, the minute you add a new entity in Salesforce, we automatically materialize the API for you. So there's never any code if I just want to have a basic read-write query API on Salesforce. I just add the entity, and then we do it for you. That's, again, one of the nice things about multi-tenancy. We define the metadata that says this is what a custom entity looks like, and then we can decide what to do in our application architecture when that new entity is put in place. And so we do. We make it very easy to build those integrations. I'm going to be talking about the data APIs. There is a way to write custom APIs. There are metadata APIs that look at the structure or the shape of a given Salesforce environment. Incidentally, the word that we use for an environment is an org. I'm going to switch to use that term now because I'm much more comfortable with it. I've been completely Salesforceified that way. And so we have basic data APIs in each org that allow interaction with that data, both from a pull and a push standpoint. I'm going to focus on the REST-based API. And as I said, this came about the time that mobile was coming to the forefront, and so we really architected it for mobile, where you have small, granular transactions that are typically, one piece of data, another piece of data, one query here, one query there. Back when we architected it, we didn't really predict that REST API would start to become a standard for enterprise integration too, which it's started to become. So that's the transformation that I'm going to talk to you about. And just to underscore the importance of API, we do roughly 4 billion transactions of enterprise transactions per day. And to put that into context, I looked up, I don't have the source, but one time recently I looked up the sort of typical Google searches per day, and it's 3.5 billion. So across all of our customers, we're doing a lot of transactions. We're shifting a lot of data. And incidentally, we're doing that across now 36 versions of the API. Well, actually, we have one version of Salesforce, but then we do version emulation back all the way to version 1, going back over 10 years. So what that means is we actually today have customers live on version 1 of the API, and it still works, which we think is a big pat on the back for us. I always put the number for yesterday up there. I forgot to look it up, so I'll just go to the website. I'll break out of the presentation here. If you ever wonder what's going on with Salesforce, just go to trust.salesforce.com. And we actually have been having some system reductions, system outages the last couple of days. But if I go to performance, you can kind of see. So yesterday, we were 3.75. Should I make that bigger? There we go. Oh, it doesn't like to stay in there. Come back here. Oh, that's annoying. So 3.75 billion transactions yesterday. Okay, so APIs are important, but we also have this multi-tenant architecture. So if every single updated record is a new request against our API, that starts to become expensive. It's expensive for us because we have to process additional transactions. It's expensive for our customers because interactions become slower and slower the bigger they get. And in fact, everything else that we do on the SOAP API and our internal API is handled in a bulk fashion. We try and do batches of, for data going in, batches of 200, data coming out, batches of 2,000. So it wasn't really in line with our typical architecture, and so that's what we set out to fix. Just to give you a few samples of what typical API interactions look like, account is a standard entity. It's in every Salesforce environment. Most enterprises need an entity that represents a business, so we just give it to you. And so if I'm going to create an account, it's going to look something like this. So there's my endpoint, and there's my body. So each, so pretty straightforward, nothing too special. Creating a record. Wait, I thought that was. Yes, actually, I already talked about automatic REST point creation, so we'll skip that. All right. So if I want to go and get a single record, it's pretty much the same, except I'm going to do an HTTP GET, and I'm going to pass in a record ID. And then you can see the response coming back. If it's a failure, then you're going to get a different payload, of course. There's actually a query endpoint, so you can kind of do ad hoc queries and have a little bit more flexible integration. So we provide that for you. There's ways to actually discover the functionality of our entity. So is this particular entity queryable? Is it not? You can go and do that. That's the describe endpoint. And then obviously we're an internet-based service, and so that means that we need to make sure that we have uniform service across all of our customers, and so we have limits, of course, right? So if you want to check up on what your limits are, you burn an API call to find out how much API calls you have. Actually, every API call comes back with a header that will tell you anyway, so you don't have to do a separate call to do this, but just as an illustration of what's possible. But as I said, too many trips. Every time serializing, deserializing the data on the server side. Every time that's burning away at our customers, sometimes very precious API calls per 24 hours. So we needed to fix that somehow. And that's where the title comes from, is that if you had a train, right, you wouldn't take one car from Amsterdam and then kind of move it down to The Hague, right, and then come back and get one car, and then go down to The Hague. That would be about the least efficient way to move cargo around. So why not take a whole bunch of requests and start to bundle them together? And so that's what we've done. So essentially, I can go and make I can sort of orchestrate my calls into one single transaction, and you can start to get better and better responses. So I can take maybe 3 of those calls, bundle them into one, and a couple more calls and bundle them into another one, therefore reducing my actual API requests. So we introduced a new endpoint. We call it batch. Sorry, composite, rather, because there are a couple of composite endpoints. The first one is batch. And with batch, I can essentially take arbitrary separate API calls, stick them together, and I can then get some information out. An example of that. There we go. So in this example, I'm creating a record. I'm going and querying the last 10 records, and then I'm checking my limits. And I do that all as one single transaction, so I've optimized my actual API calls over what used to have been 3 separate API calls. Okay? And then, of course, I get responses back. So I get a payload that looks similar to the actual payload I sent in, except I get individual status codes for individual parts of that transaction. And interestingly, individual pieces of this, so separate actual endpoints end up their own separate transactions as far as the limits that we have on the server for limiting things like CPU and runtime access. So there we go. So there's our batch object. A couple of things that just about behaviors with this. We don't want the payload to get too big, so we put limits along how many sub-requests. You could end up pretty massive, I think, at the end of this. Anything else there that I haven't already talked about? I don't think so. The one thing that I'll mention is that if you just leave it by default, if there's a failure in one part of the transaction, other transactions will actually continue. But if you want it to halt, then you can actually pass in a parameter that says, if there's a failure, halt any further transactions down the line, and then we can recover from there. The one thing about that is that the actual HTTP request will still come back as a 200 response, so as a success. So if you're not careful, it can obscure the underlying error in one of the sub-requests when on the client side. So that's all well and good, but obviously in enterprise data, we don't just have like this piece here and this piece here. We have sometimes large hierarchies of data, right? A business has contacts. Contacts may have requests or cases. A business might have opportunities where someone's selling to them. And even in some of those custom applications, there can be very deep hierarchies along the lines of orders and that sort of thing. So we thought, why not create something that would reflect this natural hierarchy of data where I have an account, I have some contacts, can't I just post them all at once? That seems to make sense. So that's what we did. This was actually an extremely tedious thing to do before, even in the SOAP API. In the SOAP API, what we need to do, we need to pass in all the parent records at once, get them back, pray to God there aren't any errors, right? Get all of, we can actually have a local client ID that we can pass in, get those client IDs, marshal them into the child record, pass those all in. So this was a very, very tedious process, even in our old enterprise integration. And instead now, we can just say, hey, here's a parent, here's a bunch of children, one big JSON package, up to 200 records total, and we can pass in a client ID so that we can actually refer back to that. So we can actually pass that client ID into the data we store in Salesforce and then reference back to it when we need to. So it looks a bit more like, whoa, that's a lot of stuff. So kind of breaking it down, right? So first thing is I have an array of parent records. And I meant to actually have that turn yellow as well. Oh, no. So first the array, then, there we go. There's the parent record. And the important thing is that this composite tree endpoint here, should I make it bigger? I love the bigger thing. Ooh, let's see, there we go, composite tree. And then whatever that thing is on the end has to match that thing right there on each of the parent records. But if you do that, everything else is fine. You can go quite a ways down, deep down into the hierarchy without trouble at all. So we create our account. What else? We want some child records with that. So there's our contacts. Again, another array with records, some cases with some records. And then the important thing is that with each of those records, at each point in the hierarchy, we pass in the client reference with those. We could customize the schema if we wanted to and actually store those in the records themselves. I didn't do that in this example, but that would make it very easy to get back to. And there we go. So that's the tree request. So would you guys like to see a little demo? Yeah? Yeah, sure. Came this far, might as well. So let's take a look here. So I did this in Postman. There's actually a really handy client application that we call the Workbench. I kind of like using an application that, well, we don't make the Workbench. It's an open source project. But using an application that I think most people are familiar with, I think kind of helps people kind of digest what's going on. So I've actually created some sample requests. And before this, I actually went into, I actually made a request to our OAuth endpoint to get a session ID. And this is one important thing. We are enterprise. Everything we do has to be secure. Companies like Coca-Cola and big banks and large technology companies and large shipping companies, if they feel their data isn't secure, we don't have a business. So everything has a session ID. I've already gone and gotten that session ID, and I'm passing it into each request. So if we go and look at, for instance, just a sample query. So this is actually using the query API right here. And if I click on generate code, it's essentially what you've already seen, right? So there's my query, select ID, name, email, from, contact, order by created date. And I do that with descending to get the last, oh, there it is. Descending, limit 10, right? So that's going to be my last 10 contacts. And then the authorization bearer token that I have in here, that's the session ID that I got out from my OAuth handshake. So that's how I've authorized that. And as you can imagine, I click on send, and provided my session's still active, woohoo, it is, I have some data. So that's really exciting. Not that exciting, actually. That's exactly how it should work. And I have some other examples here. So like actually create a contact, and there's my body to do that. So none of this stuff is too exciting, but let's actually get to some of the composite stuff. So first thing is the batch, and this is precisely the example that I gave earlier. Yes, that should work OK. So if I click on, actually, we'll go through it quickly here. So I'll go generate code. So I'm making my first request is I'm creating an account with some data in there. One thing I'm doing is this customer underscore ID underscore C. That's actually a custom field that I've put in that's meant to store the client ID. Okay, so and then next thing I do is I follow it up with that query, and then finally I make a limits call, and that's a little bit redundant, but we'll just call that demo theater, and I'll click on send. There we go. There's my response. Has errors false. That's always a good start to a demo. And if I actually go into my Salesforce environment, I'll go over here. I am using the old look user interface, not for any reason in particular. And that was a contact, wasn't it? Contact? No, account. Yes, right. So I'm going to use a little URL shortcut here. Actually, if I go to home, chances are, hello. There we go. That says some account. Did I call it some account? Oh, yeah, I did. I thought I renamed that. Never mind. There it is. So there's my some account right there. And there's my data. OK? So very straightforward. But the nice thing is that as part of that request, right, I've also gone in and gotten the most recent accounts. OK? And then I go in and get my limits as well. All right, so there's my 3 separate requests as one single request. It is hot, isn't it? I should wrap up quickly. You guys are going to get impatient with me. All right, so let's take this to the next level and do the sort of tree request here. So you can see here, I've got this nested bunch of records. I was making some changes, so hopefully this won't blow up. I didn't, mistype any JSON, but I'll go ahead and send it. It looks just like the stuff you saw on the slide. We'll send it along, and again, has errors false. And the nice thing is these reference IDs here. Now, as you can imagine, if I have a reference ID, wouldn't it be cool if I could pass that into a parameter of like a follow-up request? Oh, that's actually where we're going next with this. So, so one of the things that we want is to essentially bake a very lightweight orchestration layer into our API. So imagine the next iteration of this, which I don't have to show you because it's still in R&D, but it is on the roadmap, to be able to take that reference ID or take any field value, like an ID value, and then pass it in as a parameter in curly brackets to a subsequent request using the batch API. So that's kind of the next stage of this. OK? Any questions so far? Yeah? So let me check time. How am I doing? 15? Yeah, OK, yeah.
Right. My question is a bit quick. I'm a bit confused. Are you one transaction for all the actions that you're doing to that request. Like all the entities that are involved in that transaction are locked.
Are locked.
Yes.
So.
And if we take what you said 2 minutes ago, we can take this even further, then this would, of course, mean that you have to lock all those so you can get the reference by API.
So with our multi-tenant architecture, we're actually, we don't do database level locks because we're actually managing all of the transaction on the application tier. We don't give our customers access to our database. Our multi-tenant data model, if you actually dig into the underlying Oracle database, is a big table called data. It has 800 user-defined fields, and when you create some metadata, that's what identifies that this field for this entity, for this customer, is going to be this data type, this field name, et cetera. So actually, we don't do database level locks for this. There is some transactionality with this. In the context of the tree, it shouldn't be a problem because that is one single transaction. But getting into multiple integration clients, yeah, I'd have to think through that a little bit. Yeah. Any other questions? Yes. I'll just take yours, and then I want to wrap up with the client side, and then yeah.
Is it also possible to delete entities in the same?
So the tree is currently create only. In the roadmap is to be able to update, but that's still roadmap as well. So I do want to move on. There's just a small client-side story I want to tell around this, and then we'll wrap up, hopefully with enough time to answer any other questions that come up. So there we go. And actually, I have a duplicate slide there. So yes. Talked about basic orchestration, parameter-based values, and updates to the tree. Now, this also creates kind of a client problem because, on the one hand, this is very great. We can improve the performance of integrations, but at the same time, developers have to also build around this. And in addition to that, we have a client-based framework as well. So we have a JavaScript framework that we host. It is an open source framework called Aura that we've now implemented. Yes, we are the originators of the open source framework. No, there aren't a ton of contributors except for Salesforce people, but it is open source. Anyway, there were a few things that were important principles along this, and one of them was the efficiency of the transaction. So wanting to move things forward, I just kind of want to focus on that, as opposed to pretty much everything else that is client-side user interface stuff these days. And the big problem is this, right? I'm a Salesforce well, let's start it actually. I'm Salesforce R&D. I create one component. I'm a Salesforce customer, and my developer creates another component. I'm a Salesforce ISV, and I create a component, and all those things have to come and live in the same user interface and the same DOM without conflict and efficiently talking to the server. So how do you make sure that when you don't end up with contention for server resources on the client-side framework? Well, you essentially bake into the transaction layer, the transport layer of the client framework, the ability for all of those transactions to be aware of each other. And so that's what we did, right? Because essentially, we have these 3 blind developers all kind of building in their own silos, not even knowing if the other person exists. So imagine going and having blind into a room, taking a whole bunch of Legos, and then building the Millennium Falcon, right? It's not an easy thing to do, but that's what we sort of give our customers the ability to do that. And that's essentially it, is we have multiple XML HTTP requests without some means of orchestrating this on the client side. We're going to end up with contention for resources. So we created this feature called the action service as part of our client framework. And essentially, we don't surface XML HTTP requests through our client framework, except through this particular API. I can even defer sort of high volume transactions. So imagine logging information that I might want to get back to the server. I can actually just stick those into the queue and say, wait for a real transaction. And when that happens, you go along for the ride too. And we call that Caboose, which is where the Caboose parts, so Boxcars, Cabooses. I've now rationalized my title of my talk, which is good. So essentially, in this case, we have a whole bunch of these sort of high-volume logging transactions. Something real happens. Those get all stuck together in the boxcars, and the caboose goes along for the ride, too. So on the server side, there is an API that we surface. It looks like this. This is actually, it looks a lot like Java code. It's actually our own code. It's called Apex. And that annotation, that Aura-enabled annotation, is what says this is available to the client framework. And then if you kind of go through what this looks like, we go and get that method as a local resource. Thank you. We then, oh, there we go. I'm getting ahead of myself. There it is. We then go and we pass in some parameters, and then we set a callback function. In this case, an anonymous function, but could be a reusable one. And then we call an enqueue action, and that's what actually says, OK, now we have something that needs to happen, except if we call this one set caboose in the interim, that's going to say, actually, set it aside for now, and when something else happens, let's go and take that to the server, too. So that's kind of what that looks like. There we go. That's the basic API that we're talking about. I'm not going to demo that one. I think it's fairly straightforward how that works, because I'd rather do some Q&A if possible. We are very close to actually enabling this for offline access. So that's something that is a high priority if you imagine like a field service application, because this actually works on our mobile application. But if you can imagine a field service application, you may lose connectivity at any time. So ensuring that we can still collect data is pretty important. And then, we're looking at some way of prioritizing actions as well. So maybe a high priority one will go right away, and it won't wait for others. So maybe that might be a very high payload one where you don't want it to slow down other interactions. So that's also coming along. So there we go. So basically, this is a big architecture talk about minimizing server requests and why it's important to us, and maybe why it's important to you, and some possible ways of looking at doing that. There we go. There was a couple of other questions that I cut off. Yes?
I wasn't one of those questions.
OK, that's great.
I'm just curious because the major reason why you did it is basically to minimize, as you said, thank you, server requests, and to allow arbitrarily deeply nasty data to be fetched. So I'm curious how come, or maybe you have, explored GraphQL or Filecore as an option, because it's built exactly for that reason?
So I don't have an answer to that, because that would be the R&D department. But yeah. Okay. Yeah, in the end, when we build out something like this, typically we do look at what existing technologies are out there. Yeah. The way that things are implemented, that's not to say we couldn't use something like that in the future. So for instance, right now, we have a very lightweight event framework in our architecture. But it's implemented in a way that we could swap out what we've built with something else in the future. Right, so it's possible, but why they chose to do it this way, I don't know, to be honest. Yeah.
All right. Fair.
Yeah.
Thanks.
Any other questions? Yes. No? Oh yeah, I suppose. Yes, the microphone is running its way your direction.
Hey. Hello.
Yeah.
Yes. So I had a question actually about the offline support.
Okay.
So that was interesting that you. Had that in your slides. It would be nice to hear you elaborate on that. We're building an optimistic model with, and it's supposed to handle offline support as well. And this sounds very interesting. And also the errors. If you get an error, you mentioned it very briefly. I would love to hear more about that as well.
Okay. So on the offline support. The implementation of it is intended to be sort of seamless. So if I have the same action request that I pass in, let's say it's a query instead of actually creating data, which was the request I said. The first check would be against the offline data store. We've actually implemented it using SQL Cipher. and it's our own implementation of it. One of the things that we have to be sure of is that we don't want developers to build a client-side solution that is going to put unencrypted data into a place where it would potentially be accessible in an insecure location on the file system. So that's kind of the main problem that they were looking at solving. So in certain instances where we have a mobile device that already has an encrypted data store on it, we might utilize that. So that would be like the SQL cipher. In a case where a customer might do global encryption of hard drives for their employees, we might allow them to say, well, actually, in this case, we could actually just use the local data store on the browser, because even though it's not encrypted normally, we could use that. So essentially, we've been fairly agnostic about what the implementation of the offline data is going to be, apart from ensuring that whatever it is, it's going to be encrypted. The other question was on errors.
It was on errors, yes.
Specifically,
so when sending a batch of requests,
yep.
You said that if, say, the 5th request fails, you get something else than a 200 something back.
Yeah, yeah.
What will you do with the rest of the requests?
So each sub request is actually atomic in its own right. So if it's 3 requests and the first one is successful, that has still committed. We don't roll that back in the case of the batch. In the case of the tree, it's always atomic. So one single failure, we never store anything, which makes a lot of sense when you're dealing with storing dependencies, right? So if I have a hierarchy of dependent data, if one thing fails, there's no way I can assure that that's not going to cause something else to fail down the line. So we always roll that back as one transaction.
But what happens in the user interface, for example, if you update your data, your user data, and only the first command goes through? So
the actual client framework that I showed you is implemented in a different way than the actual API that I showed you itself. So as of today, we are only implementing it with those specifically surfaced methods. And so in that instance, we would roll back in the case of a failure on one part of that transaction. Yeah. So the API is one implementation, and the client framework is a separate implementation. Eventually, they will probably meet in the middle, and then we'll need to reconcile what that's going to be. So, but that hasn't happened yet. Any other questions? Thanks. No? All right. Well, thank you very much.